Let's take a look at 1.5 combinations of functions. So we have sum, difference, product, and quotients of functions. So when you see this notation here, f plus g of x, that just means you're adding the two functions. If you see f minus g of x, you're subtracting the second function g from the first function f. And then if you see f g, or f times g of x, that means you're multiplying the two functions. And then f divided by g of x would be f of x divided by g of x, where g of x is not equal to 0. So you might have some domain issues there. So let's take a look at example 1. All right, so we have our two functions, f of x and g of x. And in the first one, we are adding them. So this is f of x plus g of x. So we're going to say x squared plus 1 minus x. And if you want to rewrite that in descending order, that's typically how you'll see the answer, but I would accept what we had above that as well. All right, g minus f. So in this case, we're doing g of x minus f of x, right? That order matters. So we have 1 minus x and then minus x squared. Now, if we were subtracting the g of x, we would need to put that 1 minus x in parentheses. And then again, you can leave it like that, or you can reorder it in descending order by the exponents on the variable. All right, and then f times g would be f of x times g of x. So we've got x squared times 1 minus x. I put that in parentheses because we need to remember to distribute. So we get x squared minus x cubed. You can leave it like that, or if it says to write it in descending order, you can write it like that. Now, all three of those have a domain of all real numbers. There's nothing you can't plug in there. But let's take a look at D. So we have f of x divided by g of x. So we have x squared divided by 1 minus x. Now, that you can't simplify, so that is the answer, but we need to look at the domain there. Our domain is all the possible values of x, and so there's only one thing that you cannot plug in there. 1 minus x cannot equal 0, so if you were to solve that, you would subtract 1 from both sides, and then divide both sides by -1. So x cannot be -1. So we could say our domain is negative infinity to 1, and then 1 to infinity. Remember, we use parentheses for all of that because it cannot include, we always use parentheses with the infinity symbols, but we're putting a parenthesis around the 1 because it cannot equal the 1. It does not include the 1. It includes everything all the way up to 1, like 0.9999999, and everything after the 1, like 1.0000001, but it just doesn't include that 1. All right, decomposition of two functions. So the composition, not decomposition, the composition of two functions is when you're plugging one function into another, and you'll see it written this way or this way. So this is f of g of x. And you can see here, g of x is being plugged into the f function. So f of g of x, you can see it written either way. All right. So that means you're taking your x value, plugging it into g, then taking your output there and plugging that into the f function. So let's take a look at some examples of how we do that. All right, so for the first one, we're doing f of g of x. So we're taking our g function and plugging it into the x function. So we're putting that into x there. So we're going to do f of, and our g function was x minus 5. So square root of x minus 5, right? And that is our composition. Now, what can we not have under the radical? A negative. So x minus 5 has to be greater than or equal to 0. So x is greater than or equal to 5. So our domain is from 5 to infinity. And it includes the 5 because you can take the square root of 0. All right, now we're doing g of f of x. So we're taking the f function and plugging that into g. So you can see where it's a little bit different than the previous one. And so here, we know we can't have a negative inside the radical, so x has to be greater than or equal to 0. So our domain, remember, it's all the possible values of x. Doesn't matter what y ends up being. So we can include 0 and go up to infinity. So then our range would be from -5 to infinity, because when we plug 0 in to x, we get -5. So that would be the range. All right, number 3, the weekly cost of producing X units in a manufacturing process is given by the function C of X equals 48X plus 1,150. The number of units produced in T hours is given by the function X of T equals 40T. So find and interpret C of X of T. So, all right, so we are plugging in X of T into our X value. And so that would be, let's see, 48 times 4 would be 192 times 10. And so that is C of X of T. So C is the weekly cost. Oh, so the weekly cost per hour, that's what it is. All right. So we're interpreting. So what does this equation mean? Well, C is the weekly cost. And T is the number of hours. Oops. So this is, it represents the weekly cost for the number of hours of production. All right, and our domain in this case would be anything greater than 0, greater than or equal to 0. Nope, I want to include 0. We can't have negative hours, so that's why we don't want negative numbers here. So that's a constraint because it's a situation problem. It's not just a straight up function. If it was just a regular function, our domain would be all real numbers because it's a linear function. But because we're talking about t being a number of hours and we can't have negative hours, our domain has to start at 0 and it can continue on forever. So if we plug in 0, we end up with 1,150, which makes sense because there's still a cost even if they don't produce anything because they've probably bought machinery or materials or whatever. So they still have a cost even if they don't spend any time producing anything.